In the context-aware recommender system, there are three ways to build the algorithms. So the first way is to do the contextual pre-filtering. Pre, you know the word pre? Pre means before. Okay. The second idea is contextual post-filtering. Post means after. And the other is contextual modeling. So we need to make a model for the context. So for example, in the contextual pre-filtering or before, we have the data. Just remember you is the user. I is the item. C is the context. And R is the rating. And we want to do the contextual pre-filtering. It means we have the contextual data, which is C, we filter before. Using the context data, okay, we will have a new matrix, only U and I and R. And then using those data, okay, we can make two-dimensional recommender by making the interaction between user and I in order to predict the rating. So at the end, we will have the contextual recommendation. For the contextual post filtering, it means we have the data, and then we will do first on the user and item interaction to predict the rating. And then, yeah, after we do the recommendation, we will check based on the context. So the context is here, but in the pre-filtering, the context is in the early part. If we do the contextual modeling, it means I have the data and then I will make some kind of model. So the model will be based on the user, item, and the context, and I will use the rating information. And at the end, we will do the contextual recommendations. So we are going to focus on the CARS algorithm. There are two big algorithms. The first is contextual filtering. So we use context as the filter, and we will also look at the contextual modeling. In the contextual modeling, there are two kinds of contextual modeling. The first is independent and the other is dependent. So note that we focus on the context-aware collaborative filtering. You still remember what is collaborative filtering? Okay, that's correct. So we are using the user base or item base. So it is the interaction between user and item. And we assume that we have rating. For the content base, we just use the content. We don't use, yeah, in this slide, I will just use the context-aware collaborative filtering. So the contextual filtering, there are two approaches. We can look at the differential context modeling and the splitting approach. So the contextual, the differential context model, what is it? So in the differential context modeling, we have like this information. I have the user, I have movie information, I have the time, the location, and the companion, and I know the rating. In this case, as we already learned at the previous one, we have some terminology. In the differential context modeling, again, we want to check on the context. At first, we want to check the context matching. So the context matching, it means if I want to predict this user 1, and Titanic, and on the weekday at home and with sister. So what is the rating? So in this case, if I want to do the rating prediction, I can use only to match this context. So we call this context matching. So only profiles given in weekday, home, and sister. So we will check weekday, home, and sister. Okay, no. Weekday, home, and sister. Oh, no. Weekday, home, and sister. No. So if there is no similar or if there is no matching context, then we need to have some relaxation. Relaxation means if we cannot match all three attributes, let's try to relax it by using a subset of the context dimension. What is it? If the time, location, companion doesn't not match, then we will check the subset. The subset will be time, location, or time, companion, or location, companion. So in this case, I will check weekday and home. Weekday and home. Okay, it appears there is a similarity with the user 2. Let's see, time and companion. Time and companion. Weekday and sister. Okay, weekday and sister. So the most similar user is user 2. And then let's look at the location and companion. Location, it is home and sister. There is no information about location and companion. Then, okay, we will just look at the time, location, and time companion. And then at the end, we will do the context weighting. So use all profiles, but weighted by the context similarly. So I will check the similarity between user 1 and user 3 because they are similar on the time and companion. I will use the similarity between user 1 and user 2 because they are similar on the time and location. And I can again do the calculation. So in short, we want to use a subset of rating profiles in the collaborative filtering. There are some research applied such filters to use user KNN or item KNN. Do you know KNN? It is the K nearest neighbors. K nearest neighbor means K, it can be any integer. For example, if I want to know 2 nearest neighbors, or 3 nearest neighbor, 4 nearest neighbor, and so on. So using the K and N, there are two main drawbacks. So first, they just apply context as filters in one component because we need to select the neighborhood, and they just use the same selected context as filters. So if we have only time and location, so we just have only time and location, time and location, time, location. Actually, the different context dimension may be useful for different company. So yeah, that kind of things are the drawbacks, but it is the very simple problem. So for example, yeah, this is the one that I mentioned to you. We have the differential context modeling, and we want to do the context relaxation. If we use three attributes, time, location, and companion, zero record match. So we don't have any records that can be matched. We use time and location. If you use time and location only with weekday and home, okay. One record match. If we use only time, if we use only time, weekday, so there are two records match. So that's how we try to do the context relaxation. Note that a balance is required for relaxation and accuracy. How to balance this one? Yeah, we need to check if they are matching. So we can do some kind of prediction by looking at the rating and on the particular context. So if you still remember the person correlation, the person correlation means I want to look at the average of the rating, and now we will add a particular context. In this particular context means I want to check for every of the rating on the particular user in the item, particular item with the constraint or the context to minus by the average of the rating of that user on that context multiply by the similarity. So the idea is the same, but we just have more condition, which is the context. And then we will divide with the total of the similarity measures. So in the context relaxation, we call this is the DCR. We instead select only neighbors as NC1 who have issued the rating for I in a context matching C under relaxation C1. So let's say, yeah, this is the C1. Okay. So we have C1, C2, C3, C4. It depends on the relaxation that you want to use. We have the computation of R bar. It means the average of the rating. The computation of average rating U in the original equation is replaced by one in which this average baseline rating for user U is computed using a filter set of rating by the constraint. So for example, I want to know what is the rating of user. I want to know the average rating of user 1 on the particular time and location. Yeah, because I don't have a lot of data. Yeah, I have only the user 1. This one is weekend and home. Then the rating is 4. If I want to know the user 2, the average rating on particular constraint or condition, weekday and home, we have the average rating is 5. So the computation of RA in the original equation, we replace with 1 using the filter rating of the user A as above. RA with the condition 3. And when we compare the two rating profiles, we require that the rating be issued matching context relative to the C4. So relative to the C4 means relative to this one. So for every of this one, it will be based on the subset that you have in the data. So the similarity measure on this one, you can have some idea from the similarity that we had before, like Chakar similarity or dice similarity. Okay. Let's say I'm using the Chakar similarity. So there is also another method, we call it weighted Chakar similarity. In the weighted Chakar similarity, we want to look at the similarity of the intersection data. So in this case, yeah, I have the weekday and home, which is intersection. And the unique data, we have the weekday, home girlfriend, weekday, home sister. Okay. So in this equation, we call this one C and D are two contexts. So two red regions in the table above. Two red regions in the table above. Tau is the weighting factor W1, W2, W3 for the 3 dimensions. So this one we have W1, this one we have W2, and this one we have W3. Assume they are equal weights. So W1, W2, W3 equals to 1. So let's say, yeah, the time is the same weight as the location and companion. So every attribute has 1. So the Jakarta similarity C and D and tau is the number of match dimension divided by the total of all dimensions. So I have 3 dimensions. Okay, I have 3 dimensions: time, location, and companion. Among the 3 dimensions, there are 2 attributes where the attributes value are matched. So it means 2 out of 3 dimensions, they are matching. So this is the similarity. But if you want to put the weight, how to measure it? If we want to put the weight, then the weight should be added here. It means if I want to have the weight for time as 0.5 and location is 0.3 and companion is 0.2, then it means I will do 0.5 multiply by 1 because there exists the same attribute for the time plus 0.3 multiply by 1 because there exists the information at home and no information about the companion. So the girlfriend and sister is different. It's different. Then we will do the division with 0.5 plus 0.3 plus 0.2. This one is based on the 0.5, 0.3, and 0.2 here. Then we have it is 0.8 divided by 1. So you can see if we use the weighting factor, the value is 0.8. But if we use only the binary or axis, not axis, with the same weight, it is 0.667, something like this one. Okay. So the weight has more value if you can see the similarity. So we can do again with the prediction. So the prediction means using the person correlation. The idea is still the same. We want to look at the average, the average again, and then we will look at the difference of the rating given by a particular user in the item I minus by the average of that user in the particular condition multiplied by the similarity and then divided by the total similarity. So we can do the prediction for this rating based on the similarity with this item. Yeah, this is just a kind of review, yeah, from the previous person correlation. We know that when we want to do the prediction, we need to select the neighbor selection. The neighbor selection means the user among the n users. And we want to look at the neighbor contribution. It means the rating of that item compared to the average. And the difference of that rating, it will be multiplied with the similarity values. So after we have those summation, we will divide with the similarity values or the total of the similarity values. And it will be added with the average rating of that particular user or the A. So the idea, yeah, we apply this one with the context. So in short, we apply different context relaxation and context weighting to each component. Afterward, there will be optimization approach to obtain the best option for recommendation system. So this way is only to give the context on this one. So we do not need to calculate all the R, but we just need to calculate the average of the rating based on the particular context. And the similarity, you can use like the chart, you can use like dice with some weighted. And then you can do the summation. After that, you can add with the average rating. Now, there will be some ways to do the splitting. Context-aware splitting approach means I want to know how this rating can be applied for the rating prediction. Let's say the user one watch the movie one in the pool. Maybe there is a pool party. When the user one watched the movie one at the pool, so he gave rating 5. When the user two watched the movie one at the pool, so he gave also 5. The user 3, when he watched the movie in the pool, he gave rating 5. But when the user 1 watched the movie one at home, he gave the rating 2. So the same item, but different location, it has different rating. And we can have some more idea. Okay, if this is the high rating, okay, let's split with the low rating. After we split this one, then we can do the data transformation. The data transformation means with this data, we transform so that we have the user one. When the user one have M11, M11 means the user one watch movie one in the location one, U1, M12. So the user one watch movie one at the location 2. So the item is transformed from M1 into M11 or M12 or M1T and so on. So in this case, yeah, there will be question how to find such a split. How can we do this splitting? It's simple because the data is small. But how if the data is high or the data is big? Then there will be more ways to do with this one. Maybe we have only binary. The binary means I want to check the location which is full and non-full. So if it is full, then it is M11. If it is not full, then it is M10. Okay, that's easy. Just using binary. Or maybe home and non-home. If it is home, then I watch the movie M1 at home. Maybe that's it too. And non-home means I watch the movie M1 at any places, non-home. So the question is again is which one is the best or optimal split? If we call the optimal or the best split, we still have no such idea because you need to figure out the data distribution. How many category in the location? So you can see here we have full, home, and cinema. So there are 3 categories. If there are 3 categories, so maybe we need to make the item as 1, 2, and 3. If there are 3 code in this item, of course, it will be very complex if the location is big. But if the item or if the location is only 2 or 3, that's okay. But if the location is 100, then it is more complicated. We cannot find the best or we cannot do the optimal split. So it is good if you have like binary. Maybe this is the best one. So the splitting criteria can be with another approach. So some of the works in this domain in the recommender system, they use the impurity criteria and significant tests to make the selection. Yeah, if you learn in the statistics, you will learn about the t-test, z-test, or chi-square test information gain. So those are for impurity criteria for splitting. So you can just apply this one. After you split, check the t-test. After you split, check the z-test. After you split, check the chi-square test. After you split, check the information gain. If the value is relevant or the value is significantly important, then you can use it. So take the t-min. T-min is the t-test is defined using the 2 sample t-tests and computes how significantly different are the means of the rating in 2 rating subsets when the split C. So C is the context condition. For example, if it is a pool. So the bigger the value of the test is, the more likely the difference of the means in the two partition is significant. So if it is with 95 confidence interval, then okay, if the t-test or the t-min has a large value, then we can say the two partition is significant. So the two splitting approach we can have like this one. There will be some ideas for splitting. Whether you want to split by item, or you want to split by user, or you want to split by UI. UI means user and item. Let's see. If I want to split by the item, so user 1 with the item T1, the user bought the item on the weekend at home and with his friend. So I can just mention like the user 1, let's say with the T11. So maybe this is about the time on the weekend. Then the rating is 3. The user 1 with T12. So the user 1, the time on the, maybe this is weekend and home. This is weekend and cinema. So the context is 2. So the rating is 5. So I want to know if I have the user 1 and T11. If this one is, we can do the prediction because we have the data. But how if we have another splitting with user? So the user splitting means the user will have additional data. U12. U12 means the user 1 with this particular context. For example, on the weekend. So the user 12, user 1 on weekend. User 12, this is user 1 on weekend. But we have the user 11, which is user 1 and weekday. So what is the rating? And we can also do something with the user and item splitting. For example, user 12 and T11, and the rating is 3. User 12 and T12, and the rating is 5. User 12 and user T11. So what is the rating? So this kind of splitting will be also helpful to make only the user and item relationship, and we can do the rating prediction. So after we have this matrix, we can apply with the common collaborative filtering. So the recommendation process means I can find the best split to perform the splitting approach. So after splitting, we obtain the user item rating matrix. So after I do the splitting, you can have the user item. And after we have the user item, we can apply the traditional recommendation algorithms. So for example, you already learned several ways for the rating prediction using KNN, or you can apply the matrix factorization. Then I can make the matrix, and then this is the objective function with the matrix factorization. And we want to check the parameter updates based on the SGD and etc. So I will not explain the details of this one. We already learned about the matrix factorization before. Okay, let's have a break. Okay, I will continue after the break.